Hello, let's look at number 6 from year 2009, Form A. So, first I'm going to give you a little bit of time for you to look at the question, and I'm just going to highlight important facts here. That's right, first, we have to realize that the graph that we see is graph of f prime, not f itself. And it is defined also algebraically in this way. We realize that x-intercept happens when x equals -2 and when x equals this value. And g is the semicircle, meaning the first portion, where f of 0 is equal to 5. Now, okay, then let's get started. Part A. Find all values of x which the graph of f has a point of inflection. You see the point of inflection is when f prime has relative maximum or minimum. That's when we get to see the point of inflection of f. Now, this happens when, in this case, x equals -2 over here, or 0. So that becomes our answer. Let's look at part B. Here we have find f of -4 and f of 4. Okay, let's go for f of -4 first. To figure that out, we know that one given information is here. Using that, we can try to find the integration. Integration of -4 to 0 for this f prime of x dx should be, by the fundamental theorem of calculus, f of 0 minus f of -4. What is this equal to? In fact, that's equal to the area from -4 to 4 over here. But we can try to figure that area quite easily by connect the two ends of that point. Then we get to a rectangle, which is equal to 4 by 2, which is 8, minus the area of the semicircle, which is pi. R radius is equal to 2 in any direction, over 2 because it's semicircle. That somehow should be equal to f of 0, which is equal to 5, minus what we're looking for, f of -4. Once you simplify this one, you will realize that f of 4 must be equal to 2 pi when you bring this one over to the other side, and then minus 3 becomes our answer. On the other hand, how about f of 4? F of 4 can be figured out, found by from 0 to 4 for f of x dx. Based upon the fundamental theorem of calculus, this must be equal to f of 4, which is what we're looking for, minus f of 0, which is given. Or in fact, prime right over here. F prime on this interval would have been the bottom expression. So that becomes integral 0 to 4 for 5x to the 5 times e to the negative x over 3 minus 3 dx. Now that becomes, when you integrate this one, we will end up getting -15 e to the negative x over 3 minus 3x for 0 through 4. Once you plug in 4, we get to realize that it's equal to -15 over e to the 4 over 3 power minus 12, and subtracting, once you plug in 0, we get -15, but nothing from the other side. So once you simplify this one, we'll end up getting 3 minus 15 over e to the 4 over 3 power. That becomes f of 4. Now let's look at part C. Part C, it says find the absolute maximum. Whenever we want to look at the absolute maximum, we have to check upon two kinds of points. One is the relative minimum or relative maximum, and endpoint. Now, that means we have three candidates. Here, and here, and here. Out of when x equals -4, and then critical points based upon the given was 3 ln of 5/3, and then the last value was when x equals 4. Now let's look at these two values. You see this portion has the negative area, so therefore when x was equal to this value, it was higher for f than this one because it lost value by the negative area through integration. How about when x equals -4? From -4 to particular value here that's given, it always has been the positive area. So therefore this value must be greater than this one. Hence our final answer becomes when x equals 3 ln of 5/3. That becomes our answer. And justification is something that you can just write it up based upon what we just described over here. Alright, that's it. I'll see you later. Bye.